the two files that you've got in your training environment. You've had plenty of time to do that, so I hope you've done it. But you raised the question that says you can't put before triggers on your files of your production system because it will crash your production system, which is unfortunately very true. So I have had this question before. I designed a solution with it before to stop shooting yourself in the foot by using triggers. However, I couldn't find the code. I don't know what happened to it. I don't know where it went. So I had to rebuild and redesign the solution, which I have done. And we are now going to look at that solution. And with your help, because I want you to concentrate on this one, because this is going to pull a lot of the stuff we've already talked about. It's going to pull it together and suddenly become a lot more meaningful. So I need you to focus, and I need contributions from you whenever I ask for them. Right, so let's first of all look at the scenario that we have. We could have, in our database, we could have trigger-enabled programs, and we could have legacy programs that are not trigger-enabled. Obviously, when you start, you won't have any of the first, you will have all of the second. But as you move forward, you'll get more trigger-enabled programs and fewer legacy programs. So what happens here? Well, of course, the trigger-enabled program, hopefully, is using an I/O server now to get at a table. And the legacy program, if you haven't managed to even get as far as the I/O server, it will be going straight into RDBMS with an FSpec. Not a problem, not a hassle. RDBMS will call the before trigger, and in a normal circumstance, it would return to the RDBMS with no errors, and it would then return control to the program. So either of that type of program would be quite comfortable if there was no error discovered by the trigger. But the problem arises when you have an escape message returned from the trigger indicating there were errors, because your legacy program will fail because it will get an error that it's not expecting and not handling. And obviously, you do not want to go and change every single legacy program immediately that deals with this particular file, because that's just going to be too much of a strain. And it's actually, to be honest with you, what terrifies people all the time. The enormous scope of what you have to do to make this work. So the solution is we need something to check to see whether the program that made the call is a legacy program or a trigger-enabled program. Now, this check, the only way it can find out, because remember, there is no communication between the trigger and the program. There's no direct way of communicating between these two. So I mulled this over for quite some time, and I came to the conclusion that the simplest way to do this is to use two different schemas. Right, what will happen? Sorry, let me get back here before I go. What we'll do is we need this routine to check the legacy, and we're going to add to it a log file, because the purpose behind this is if we're dealing with a legacy program where we can't process the error messages, we want to log any error messages that occur so you have a record of them. And you can look at them and you can deal with them and you can decide whether to add it to the trigger, to change the program, whatever. So we need to check for legacy programs, and we need a log file with an iOS, which is automatic in my environment, to log errors that are occurring. So let's see, what does this legacy program do? The only way that I can find out whether it is a legacy program or a trigger program is to interrogate the call stack. To look at the call stack and remember the trigger is a program, therefore it will have a PEP procedure, program entry point procedure, in the call stack. So my check legacy will go back up the call stack looking for the first PEP. Then RDBMS, the IO server, and everything else here is all procedures. So I simply go back up the call stack until I find the next PEP or program entry point. When I find it, I know that I'm dealing with the calling program. So I can then look and I can check information about that calling program. And the one thing that's easy to check is the schema from which the call came. I can find out what the program name is, and I can find out what the schema is that called the RDBMS either through the IO server or through directly. I can find out what the program name is and what the schema or library is. So my suggestion is that all your legacy systems are in your old schema. Your legacy programs are all in your existing schema. What we do is we create a new schema, and when you change programs to handle IO servers and handle trigger errors, you move that program to a new schema. This is a pair of schemas, and as you deal with a program, you can move it across into the new schema. Now, what this allows me to do in the call stack is I can find out which library, which schema the call came from. And that will tell me whether it is or it isn't a legacy program. It's by far, in my chasing this thing around to try and find a solution, this is by far the simplest method of doing it. It doesn't require any additional parameters. It doesn't require any fancy coding or anything else. It's quite simple. When you fix a program, you move it into the new schema, the fixed schema. The check legacy then decides and returns an indicator to the trigger to say, yes, it is a legacy, or no, it isn't. If it's not a legacy program, it means it can handle the trigger. We would send the escape message back. If it's a legacy program, we log an error message, and then we return a conventional response which will not crash this program. So that or that, depending on what the check legacy finds in the call stack. Okay. Are you with me so far? Because now I've got a couple of questions to ask you, and I need somebody to feed me an answer.
I'm with you, Tommy.
Good. This bit of code here that checks the legacy, it is reading the call stack. What and how do you think we should write that piece of code as what? And where should we put it? While you are thinking of that, I am going to put up a screen so that you have a nice blank RDI screen, and I'm going to show you some code. You see, the thing is, this is part of the error handling processes, is it not? So there is an error handler module. You've got it. This is error handler 03. Yours is ERR SRV at 03. And this module already uses the API that reads the call stack. Okay. So in this case, the logical place to put that check legacy program, this one here, the logical place to put that would be where the module is already handling there's already an API defined within ERH, my case, in your case, ERR, SRV03. This is the module that contains error handler services or utilities. So let's have a look at what I've done to create this. Now, you will be able to replicate this quite easily from this code because it's not that long. Here is the procedure called legacy to check if the client program is in a legacy schema. This is easy. And there is the return variable. That's the parameter interface definition. And the return variable is an indicator. I will say again, this is not so much a procedure as a function because functions return values. And a function can be used in an expression. So let's have a look. There's a call to the call stack. It immediately calls the call stack and determines the call stack entry parameter or entry pointer by using the pointer to the data structure that is returned plus the offset to the call stack. So there is your pointer plus offset to give me, there is your call stack entry there. And this is, sorry, this is the call stack return variable. It's 65534 long. And these are the headers. And the call stack entry offset is there. This pointer addresses that. So if I add the call stack entry offset to that pointer, I get this, on which this data structure is based. As a result, this is a call stack entry. And the first thing in the call stack entry is the length of this call stack entry. Okay, so I do this. I have found my first entry by doing that. Now I do while not PEP. Now PEP is a procedure that was already here in this module. This is another reason I use this module, because there's a PEP procedure in here which checks to see whether the call stack entry is or isn't a PEP. And you can see it returns a 1 if it's a PEP and it returns a 0 if it isn't. So that procedure was already in this module because it's used for something else. So I benefit from that by just simply adding this as a new procedure to an existing module. Here, I check is the first one. Do while not PEP. So if it's not a PEP, I will add the length to the entry and move on to the next call stack entry. This is how you navigate down a list of entries. By adding a length to a pointer, you move down a list of entries. So I keep doing this until I find the PEP. That PEP is the trigger program, because that's the first one you'll find. So I then drop out of this loop, add another length to the call stack entry pointer, which moves me down to the next entry, and I do the same loop, exactly the same loop again. But this time, if I hit a PEP, I know I've got the calling program, because the trigger's a program, and the next program I will find is the calling program. So once I've done that, I will scan the CSE, and I'm looking for the program library. And I'm looking for a match to a library list. Now, I have got a set of golden rules that I cram down everybody's throat at every opportunity. And probably the first of these golden rules is never hard code library names, ever, unless it's QTemp. I keep saying that, and I keep saying that over and over again. Never hard code library names, because they come back to bite you for sure. Except now I'm going to break my own rule, because if you look at what I'm looking at the call stack entries program library, and I'm scanning a thing called liblist to see whether I can find a match. And liblist is a set of hard-coded schema names. In this instance, this is acceptable, because this will be a list of all the legacy schemas. You might have more than one. And remember, if you've got a developers, test, and production environment, you will have a legacy schema and a new schema in each of those environments. So you could have 3, 6, 9, I don't know how many schemas you might have in here that contain legacy code. So you hard code a list of schemas here that are legacy schemas. Then when I come down to this scan, if the scan is not equal to 0, i.e., it means that I have found a match in that list, I return a 1, which says, yes, I've got a legacy program. If I don't find a match, no, I've got a non-legacy program. And that is what that procedure does. All it does. It simply returns to the trigger an indicator to say, yes, this is a legacy, or no, this is not a legacy. By the way, here I said we need an error log file, and I automatically created an IO server to serve that error log file. I do that automatically every single time I create a file. It's just a habit. So if I'm going to show you this thing, I'm going to show you the list. Yeah. These are all the error service programs. There you will see is my log file. And here is the copybook. And there is the IO server for the error log file. Now, you've created a procedure because you've done this already. So you know that an I/O server is a module, but it has a procedure, one procedure in it. And this one is a module with one procedure. Where do I put this I/O server? Now you created a program. What did you call it, Bernard? That was for your I/O servers?
One for Pradar?
Yeah. You created a an I/O services service program.
Yeah,
you put
it's
those I/O services.
PRD. It's PROD_A01. Well, Joel,
Okay.
how did you name it? Oh, Joel is.
Let me check.
Tell me something.
The IO is called.
If you get up and leave, does your avatar leave as well, or does it stay behind?
Good question.
The IO is Pradard with $sign.
Okay, yeah. So would it be logical to put this I/O server into that service program? And if you think so, this is an I/O server which has been put there to read, write, and update the error log file, all part of handling trigger errors or error handling. Doesn't it make more sense to put this into your error handlers?
Yeah, sounds good.
And all you do in order to achieve that, if I can find this, is you create your program, your error handler service, you know, the C program, CL program to compile it. There's your modules for your service program. We are looking at error service 3. You just add the error handler in the bottom. And then you change the binding directory. You put the legacy in there, and you put the error log file, IO server for error log file in the bottom. And that's it. Then you compile your error handlers again, and you now have an IO server embedded in your error handler service program. But that's the more logical place to put it, in my opinion. If you disagree with me, please say so. Okay.
The check legacy, Tommy.
Yes.
I'm not sure I like the idea of having two library or two schema.
Okay.
What if we instead have a table with program name listed that would tell if this is a new, if this is a legacy program or not.
Okay. I'm going to say something here which we are only probably, which I actually hadn't even planned to cover in this session. A table would have the program name in it and nothing else. It would be a single field in that file, which would be the key, correct?
Yeah.
And the check legacy would then have to do an IO on that in order to...
He finds the PEP, chain to that file, get the you know, If it does, you know, it does
In fact,
the trick.
in fact, you wouldn't need this then. You could do, sorry, you could do that check in the trigger.
Okay, because in the trigger we have the PEP program, the calling program. No,
No,
we don't.
you wouldn't need to. Would you? No, you wouldn't. No, you would still need to get the call stack because you need the name of the calling program. So check legacy.
Yes.
Yes. Sorry. Thank you. You're making me think. You would need the call stack to get the program name, and then you would check it to see whether it's in the file. A solution, yes, I do agree with you. Then you would just have to remember that when you changed a program to become trigger enabled, you would have to add its name to that table.
Yeah.
Which you could do, and you would have to manage that in some way to make sure. Well, you would create a problem if you put the name of a legacy program into that table.
Mm-hmm.
You would create a problem for yourself. Yeah. If you did not put a trigger enabled program into that file, it would not cause you a problem. You follow me? Yeah. So one way it would be a problem and the other way wouldn't. Remember,
it's additional management because we have to manage that table, but
yes,
having two schema,
okay,
it's also additional management. So it's
6 of one, half a dozen of the other. Yeah. I think maybe you're right though, except you have an additional IO which costs you an overhead. Okay, so I'm going to make a comment here. In this particular case, there's a faster way to do this, much faster way to do this. And that's using a thing called a user index, which is the big brother of the what is it called? The data, not the data area. What's the other one?
Data queue.
Data queue. It's the big brother of the data queue. It's about 10 to 20 times faster than an IO on a file. And unfortunately, you would need a program to write into it, but that's all. So you could do it either of the two ways. If there's an overhead issue, because what you're doing is you're doing an IO every single time you call that table or access that table. And the more tables you convert to add triggers to, the more overhead IOs you're going to develop. So you could start with a file, but you might find you would rather change it to a user index, and that will be another session I have to add on to the bottom of this thing. Yeah. But yes, that's perfectly acceptable alternative. I can't see a problem with it. And I do agree with you that at least it saves you from messing up. It has another advantage, which I hadn't thought of. You're quite right. See, I do these courses for me to learn, not for you. It means that if you've got them in a if you've got the program in a development environment or a test environment and you're testing it in a test environment, you put its name. Oh, be careful. Because if you're testing it, i.e. it's not yet in production, and you put its name into that file, then it's going to cause the production environment a problem. You might need different tables for the different environments.
Yeah.
You follow what I'm saying with that?
Yeah.
I will think about it and I'll come back to you. But yes, it is definitely a viable alternative if you don't like the option of 2 schemas or 4 schemas or 6 schemas or whatever. And obviously the code, this code here where it's building the legacy, will become different. Here,
Yep.
You wouldn't scan. You would do a chain or a read or something to the IO server.
Yep.
Okay, no problem. So we've got that one solved. We've got that little problem sorted out. So now we go back to the trigger. Now I'm going to kill these. And I'm going to go and find my work with ABC source members. What I did first is I created two triggers. I created a B1. I created a B0 first. And I started modifying it. So I decided to create a B1, which I use the generator for. And this is a standard B1 trigger. And then I created a B0, which is where I was going to be doing my changes. So I'm now going to get that out of the way. And I'm going to bring this B1 over to the side. Now, B1 is your standard template trigger, which you hopefully have already built for ProdOrd and the other one as well. I'm not going to force you to answer me on that one.
Joel did it.
Okay.
Yes, I did the
You
product.
did that.
But the other
Wonderful.
one.
Wonderful. And I'll make this bigger just so it's easier to read, because I've noticed that in the recordings, it's not quite as easy to read. Okay, so I made some changes to B0, partly because of my OCD. As I've told you before, I am OCD. The template puts this parameter list in full. And that goes into every single trigger. And I'm tired of seeing all of that code every single time. So I took it out and I created a copybook. I love copybooks. They cut down so much hassle with code. I created a copybook that contains, as you can see, contains the pointer and the whole structure. So that instead of having this whole thing, I can just put in a single line, which is a copybook. And in fact, I use that all over my triggers. This was only done in order to clearly illustrate in the template what these what these were. It doesn't cost you anything. You can change it or not as you choose. Similarly, with all these errors prototypes, I've replaced them in this trigger with the copybooks that are related to each one of them. That's just to compress the code, and I'm comfortable. And with RDI, it's so easy to see what's in them that you really don't need to have the code expanded in full. Like I can see what's in this one just by doing that. So there was no need to have this. Okay. Now, in the data definitions, no, I lie. In the prototypes, I defined a procedure called legacy. And that's the return value for the function, the indicator. And that's the definition of the procedure. It's quite simple. And of course, because we might be logging an error, if it is a legacy schema, I've had to create a procedure called log error. Now, anybody understand why I created a procedure called log error?
It's to handle the the error if it's a legacy program,
Right. And also because it's going to appear in every single trigger. Every single one. Because as you add triggers to your programs, you're going to have this in your trigger. In fact, this is going to become your standard before trigger for all your programs until everything is out of your legacy system. Okay. Notice something that I did here. In the log error procedure, I put through the message ID, the message file, and the message data. And I would, when I build a template for this, I'm going to make this into a copybook because it's going to be consistent. But I didn't do it this time because there's still one parameter that's got to be added to this. And you're going to work out what it is and where it's got to go. Other than that, it's all very much the same. Until we get here, at the beginning of the trigger, I set the legacy indicator by calling the legacy routine. Right up front in the trigger, I do the call and I set the legacy indicator. So now the trigger knows whether it's dealing with a legacy program or not. I do that right up there rather than have to worry about doing it in a number of other places. So it's done up front, right there. Okay? Please stop me if you have any questions because this is important. Right, when we get to the point where we check the event and do insert, delete, update, the routines for the different events, we get to this point where we say if error. If error. This then is the error handler. Now, whether this program is a legacy program or not, I want to move all the diagnostic errors. I want to move all the diagnostic errors up into the message queue of the calling program. So error handler 05 will do that. It will move the diagnostic program, the diagnostic error messages to RDBMS that will move them out either to the IO server or to the calling program because I'm putting the diagnostic messages from the trigger into the job log of the calling program because that's where the information about what errors were encountered is found. But only if it's not a legacy will I send the error the escape message saying there's an error in the trigger program. Okay. So I will always move any diagnostic messages up, but only if it's non-legacy will I send the escape message. That's this thing or that thing, this thing or that thing. If there's an on error, this on error condition tells me that it's an unexpected error somewhere in this block of code here. I still send up all the diagnostics that I can find, and any error messages I can find, they get moved up as diagnostics. If it's a legacy indicator, log the error, else escape message. Now this, yes.
Just you have if error and on error, and if error, it's going to execute ERH 11.
Error is an indicator.
Yes.
That's the error indicator. Yeah.
Yes. Is it going to do it twice? ERH 11?
No. Because
it's going to do it on if error and
if
do it
error,
again on error.
No, but Remember, I only get into this routine. This routine, I only get into if I find an error anywhere in this code. An unexpected error. If there's no error in this code, I won't go in here.
Yeah, but
I'll
there
only
is.
go in here.
Okay.
If
But
it is a legacy program, I will come to here. I will not go here. I will skip here to here.
Yeah, I agree. But yeah, we're on error. We're on error because if error, so there is an error. Okay.
Yeah, but this error is an error indicator. It's not an on error condition.
Okay.
I'll follow me with this because we'll go into the validation routine here. Let's go into a validation routine. Here's the record code. If the record code is equal to blank, let us assume this is not a true validation. Please understand that. But I've assumed that if it's blank, it's an error. So I turn the error indicator on. That's an indicator, not an on-error condition. If it's a legacy indicator, I log the error to the file. That's the log error routine. Okay?
Yeah.
If it isn't,
it's an error indicator. It's not a database error or something.
No, it's not. It's an error indicator. Maybe I should have been clearer and made it ERRIND.
But no, that's okay. Just having to, we have to.
It's an error indicator. It's not the on-error condition, which is a different circumstance altogether.
Okay.
The on-error condition is what picks up any errors between the monitor and the on-error. Anything in error between those two will pick up an on-error condition. But here I set the error indicator on, indicating there was an error.
Yeah.
Okay. If it's a legacy indicator, I log it to the file. And then in either case, in both cases, I send a diagnostic message to the message queue of the RDBMS, because that'll go back to the job log of the program, of the job that's running. So I'm only controlling the actual error message itself. So every one of these log entries will behave the same way. I only did it for the first one. All of these others will be changed in exactly the same way, because this can be put into the template like this. Okay. Are we sure about this error?
Yeah, I'm okay.
You're okay with it? Because
I have a question.
Yes.
Instead of having to write the code if legacy indicator, log error, and if, could we have write this code into the error handling EAR10 or 05 that adding a parameter say that do the log error at the same time.
I hear you, but there you're talking about another parameter, okay? And there is actually a very, very good reason why I do it here. And I'll get to it. If you move it into the error handler, the ERH10, it's another level down in the call stack, and you're going to lose something that I'll show you now. Okay, I hear you, what you're saying, but this, because this is, it's possible to put this into a template. You won't have to write this code, put it into the template, and it will simply write the same code in every one of these field procedures right the way through the whole lot. I can either do the template for you, Bernard, or are you going to take a crack at it yourself?
The new template for this?
For this trigger, yeah, this type of trigger. Would you prefer? Would you prefer me to do it?
Well,
yeah.
Ask Joel. Ask Joel.
Joel.
Well, I don't mind doing it. It's not very complicated.
Okay. All right. Well, if you have a problem, just buzz me and I'll help you with it. Okay. Right. Let's let me just get rid of this camera again. So this logs the error. Now, this log error, you saw it here. I defined it as a procedure. Where did I put this procedure? And the answer to that is I put the procedure into ERH03, the error handler 03 module, because that's the logical place for it to go. Here it is here. There it is there. I put in a procedure into this handler that's the log error. It's already in your binding in your binding directory. It's an error handler procedure. It's only used for handling of errors. It's only used for logging of errors. So it's a sensible place to put it, is inside your log handler, your error handler. So you will see that this has the same 3 parameters as any call to any error handler. Those are the standard 3 parameters for any error handler. And what is this error log going to do? Right, first of all, we have defined the IO server as a copybook, and there is the definition of the error IO server for the error log file. So that goes into this procedure as well. And you will see it's got the 3 parameters, plus it's got the key, the length, the pointer, and the record. Pretty much standard for any IO server. Clear the error log file. The first thing I do is I clear the error log, because there could be leftovers from the last call, and I want to clear them out. Because remember, this is running in the same activation group. That file will remain open, and all the data structures and everything else will also remain open. So there could be an error. Right. Now, let me just go back and look at the contents of this error log file. Right. This is the contents that I have put into the error log file. File name, event, the program name, the log date timestamp, the error message, the replacement text, and then a before and an after image of the record. Now, because this record can be from any file, I've put a varchar, variable character length, and I've got 2048. If you have files longer than 2048 record length, you're going to have to make changes to that. So I felt that that is sufficient information in the log file for you to be able to see what has gone wrong, what the error was, and if necessary, you will be able to compare the before and after images to see what the change was, and so on and so forth. You also have the actual error message and the error text. So you can recreate the error message that has been sent. Okay, so that is what the log file looks like. So here in this, clear the error log file. I have file name, event, and program. Then I have the log date timestamp. That's easy. I can put that in right here. No need to worry about that. I'm getting the MI and the MF. I can put those in without any problem. And now this is where I need you to just think here. I still need file name, event, and program name. And I need a before and an after image. How do I fill those into the log record? I'm going to give you a little bit of thinking time. And see if you can come up with a simple answer. And this, by the way, Diane, is the reason why you can't put this error log into the ERH 10 or 11. I need that information. Where is that information?
That was in the the include for looks like this one, and then yeah, the file name should be there.
It is. This is the trigger parameter list for every trigger. There's the file name. There's the event.
Yeah. So
those two are in there.
Yeah.
We
the
also,
program name should come from the legacy check.
Yeah, exactly. And where the before and after image, where do they come from?
This is coming from the the trigger program, which is
N and O.
Yeah.
Which you can get by taking this pointer, okay, and adding the old record offset to the before image and the new record offset for the after image. And I know how long that record is because I've been given the length. So if I simply add a parameter here, and by the way, a rule of thumb, when you're passing pointers as parameters, pass them by value. If you pass them by reference, remember, if parameters are normally passed by reference, and the reference is a pointer. If you pass a pointer parameter by reference, sometimes it gets screwed up. So the recommendation is you pass pointers as parameters by value. And that's the way you do it. So what have I got here in my data definitions? I've added the trigger parameter list. You see why I use a copybook now? The trigger parameter list is here. So by doing that and going back to the program here, where I call this all I have to do here is I have to insert PP in the front of that parameter list there. Now that passes the pointer to the data structure to there. And that is, where is it? Where is it? I've lost it. It's in here, the data. And that is the pointer. There, that's the pointer. So in fact, what I need to do here is I cannot have that the same name. I simply move this pointer to the data structure there, to PP. That means this I overlay over the one that the trigger's got. So I have all the details for this from the trigger, just by passing the pointer. Okay?
Yeah.
That's the one piece of magic in this. I'm not going to ask you whether you're impressed, because I know you are. Yeah.
On the left, to me,
Yeah.
there's on your line there, if and record code is blank, on error, and so forth.
Yeah.
Why don't you put and else?
Else what?
Well, if legacy log error, and then
Yes.
you do your ERH10 as well.
Yeah, I want the ERH10, whether it's a
Yes.
legacy or not.
Yes.
I
Okay.
want that error to be sent back. Remember, that's not an escape message.
Oh,
It's a
that's
diagnostic.
information. Okay.
It's a
Okay,
diagnostic message. So it's information. I want that to go back to the job log.
Okay. Okay.
So I'm doing that in not an else condition.
Yeah.
Okay. Right.
Oh,
So
I thought I caught you, but okay.
some people have, and they keep trying, a promise. Okay, so this parameter is P1. So let's go down here and look at this error handler. And this one, we can take out that. And we do P1 dot. And it's the file name like that. Okay. P1. P1 dot. Here we want the event. So we take P1 dot, pick up the event. Now, this one is going to be a little more difficult, because we have to prepare something here. Now, I would like to hand it over to you to talk me through it, but I don't think we've got long enough, to be honest with you. Right. So we are, what's the first thing we have to do here? We have to set the before image. We have to sorry, I actually thought this through 2 weeks ago when I was doing it, but I've now forgotten it, which is an embarrassing thing to have to say, but
Yeah, we have to take the pointer and add the offset of the old record and the offset of the plus the length.
Okay, what we can do here to make it simple, we can create a data element. Where is it? Where's my data? Yeah. Somewhere down here. You can do a DCL standalone field image variable character 2048. Remember what I said? The 2048 will have to change in length if you've got any records longer than that. Do you have any records longer than that?
Oh, good question. Francis?
Okay, he can look that one up in the meantime. So what we would do here is we would say image equals no. I thought this one through. Sorry, image varchar based on so I'm doing this as I go along, so bear with me. Okay. Record pointer. And we base this on ETR. Okay. So we create a space and we create a record image based on the pointer. Okay. So we now say here that the image record pointer is equal to EP plus P1 dot old offset. Okay. Everybody happy that I've changed the record pointer to now point to the old image? Come on, people. You agree?
Yes.
Okay.
I do.
I want to be very sure you're with me. Then what I do is I say, well, I can say error log F before image, so we can just simply delete these two lines. Before image equals image, which is the variable length field image, insert percentage SUBST substring of image starting at 1 for a length of P1 old lengths. Is my code right?
It's good to me.
Okay.
What's important is Joel has to understand that.
Well,
And Francis.
Joel and Francis are being very quiet.
Yeah, Francis is not there anymore. His PC crashed.
Oh, his PC crashed. Oh, boy.
Oh dear.
I'll be back.
He's going to have to watch the recording
Yes.
and send me letters.
I'll explain to him.
Okay. And then this one, of course, is exactly the same except it's
The new.
new length. Where is this thing? New length. Okay. And then, of course, I can call error log $, except I've still got to find the program name. And there's something wrong with these two. They would be perfectly okay if it was an update. What happens if it's an insert?
Okay, we need to test the event.
Yeah.
Okay.
We need to make sure, so we can either test the event but I don't want to test the event because I've got 3 tests. I've got to test for update. I've got to test for insert and do only the new. I've got to test for update and do both. Or I've got to test for delete and only do the new old. You follow me? So that's a bit of a nuisance.
Yes, but why bother with that? Because the worst thing would be that the old or the new record will be empty, no?
Well, old offset. What happens if it's an insert? What is the value in old offset?
So the the pointer is not there anyway. It's not reserved.
The pointer will always be there because
yes, but the offset will not be there anyway.
It'll be 0. It'll be 0.
It's going to be 0. Okay.
So I'm going to move into the before image. Unfortunately, I'm going to be moving into the before image, starting there for the length of that which is 0. So the old length will also be 0.
Okay.
Which will, of course, cause this statement to crash because old length is invalid if it's 0. You follow me?
Yeah, but I thought old offset was something anyway. It was reserving the memory for it, even though it's
no, it doesn't do that.
Okay.
If it's an insert, the old offset will be 0, and if it's a delete, the new offset will be 0.
Yes.
Okay.
Yes.
So what we need to do here is simply to put in if P1
that's 0.
old offset not equal 0. That's all we need to do, and we need the same thing with the new offset here. We've cleared it, so it will be blank. In fact, it will be, I think when you clear a varchar record that hasn't got an alloc on it, I think it goes to 1 byte or something like that. It's a 0 length field. So that would be, now what about this one?
Okay, we got to go back to the PEP, put the PEP, but the legacy check.
Okay. Here's more magic, which if you're thinking about activation groups and the use of APIs and the use of pointers, Remember, all of this is taking place in the same activation group. Okay. And this legacy procedure was run at the beginning of the trigger. So the current call stack entry that is in this data structure is still the one that was read by the legacy program.
Yep.
And there's the program name. Nothing has changed, even though you called it in a different procedure. Okay. This data structure is in the global data area. Have I lost somebody else? Ah,
Francis is coming back.
Francis is coming back. Okay.
Sorry, I was lost somewhere in the space.
Yeah, it happened to me last week as well. I know how it feels. Okay, so this was populated by the call to the legacy. It's in the same activation group, and it's in the global data definitions, i.e. it's a data statement that happens before the first procedure. Therefore, it's global for the module, i.e. it's accessible to all procedures in this module. Follow me. So all I have to do to get this populated is to go CSE full stop prog name colon. Do you follow it? Because this was not the way I solved this problem originally. It's not. This is a better method, but it's also more convoluted or involved. But because that data structure was picked up and populated by this program, is still returning the indicator. Oh, hang on, this is going to have to change because of what you wanted, Bernard. That this, instead of comparing libraries, this is going to have to chain to a file and see whether the program name is in that file. And the log error, you go back to the trigger and then back here, you've still got the same data in that data structure. So you can use it to populate the error log file. Any questions?
Joel Luvick.
There better be.
Good.
Well, tell me, why do we have to call again the scan? The scan that you showed us just before, for the legacy, to get the legacy.
Where am I?
Yeah, there.
This before and after image, you mean this one here?
Not the before and
this
after image, the one for
here.
the legacy. Yes.
Yeah.
Why is this? This was made originally, so at this level we don't need it anymore. We just need the data structure.
This you would not need, because here, instead of scanning a hard-coded list, you would be reading a record off your file. You suggested we put the program names in a file.
Yes, but this was already made. We know that we know it's a legacy or not, and we have the data structure populated already.
But you.
So why do we have to do it again?
Which data structure have we got populated? This one, the call stack entry.
CSE. Yeah.
But this doesn't tell you whether it's a legacy. It tells you what the program name and program library are, but it does not tell you whether it's a legacy program or not.
Well, I thought that test was already made at that level.
No, remember we had a list of schemas, hard-coded schemas here, that were the legacy schemas, and you took the program name, the library name, and you scanned the list of libraries to see whether this program was in the list. Now, this piece is going to be replaced by I can tell you what it's going to be replaced by. It's going to be replaced by some file $.
Yeah.
Okay.
I understand.
And a read using the CSE program as the key.
Okay.
CSE program is a key, and it would simply say insert if.
Yeah, something like that.
If not, file something or other. Return 1. So if it's not in your file, return 1 to say that it is a legacy. If it is in the file, return 0 to say, well, you know what I mean.
Yeah.
One or the other. So that scan would then no longer be there, and this list here would come out.
Yeah.
Okay, so that would simply be a read. In a future iteration of this, I will talk to you about a user index, which is the perfect solution for this. And as I said, they are the big daddy of data queues, because a user index can be much bigger, and it is self-sequencing and easy, much faster to access than a file. Okay. So this trigger, which, Joel, you can have a crack at making this trigger into a template. We're going to have to do something about this, because we need to enhance your ERR server 03 to get it right with all of these in it. And then, of course, we need to take the trigger program, which is here, and we have to create a template from it so that you can repeat this without having to go through all this nonsense every time. And Diane, this is the reason, this pointer is the reason why this is done in the trigger and not in the error handler. Because the error handler won't have that pointer to pass through. Okay. This was quicker than I thought it was going to be.
When you declare the pointer as PTR, you you cannot use PP because PP is already there in a data structure.
Yes, it's in the data structure.
Yeah.
And so I use this. The names here, by the way, can be anything. They're irrelevant. They have no effect on what is passed.
Okay.
The parameters are passed by attribute and position. The name does not have to be the same at both ends or any of that sort of thing.
Yeah.
But passed by value, I must warn you about pointers, though. They have a peculiar habit. If you use pointer arithmetic, like, for example, this or that. For example, if I did this without defining the record pointer here, the compiler recognizes this statement as a, where am I? I lost myself. Recognizes this as pointer, as that's a pointer, and it knows this is on offset, it's numeric, so it assumes the result is going to be a pointer, and it will auto-define. One of the things I don't like about this new version of this compiler, it will auto-define record pointer, and it will put it into this procedure. It won't put it into the global data definitions. It will put it into this procedure in which this is being used. So if you do the same thing in another procedure, you will have two record pointers, one defined in each of the two, and you can't use them between procedures. So just be very careful about that. There are one or two other fields that do auto-define as well. I'm not sure what they are at this moment. Pointers definitely is one of them, and it'll just generate a definition for itself because it knows it has to be a pointer. And you've given it a name there, so it will generate a pointer in this procedure's data area. And it's not great. I chased the bug for almost a week because of that.
Oh.
I could not find out why this program was falling flat on its face. Because I thought I'd defined this record pointer and it was common to all the procedures, and it wasn't, and it just would not work. I chased it for a week. So I'm giving you the benefit of my neurosis. Questions? Does it fit together for you? Or is there anything else?
I have a question. We can do that.
Eh? Say that again.
There's something I don't understand. I think that Joel want to say something. I don't understand why we couldn't change ERH10 and adding parameter like the PP, and in the ERH10, this one will do the log error if it has two. So all the trigger program won't have the code for log error. Okay. They will always have the parameter PP, but it will be only in the I think it's a procedure ERH10 or 05 or
except for one small thing. ERH, or in your case ERR 05, 10, all the ERRs are not only used in triggers. They are used in all sorts of other procedures. They're used in IO servers. They are used in your, eventually you will start using them in, eventually you will start using them in these programs as well. When you enable for a trigger, you will start using your ERRs of different types. So if you have some of them using pointers, and you're using them without being able to provide the pointer, and they've got code that's based on that pointer, you have to make conditional code. Whereas this is very unique to the triggers. So the triggers are dealing with it. What I've done is I've created the legacy as a procedure outside the trigger. I have created the IO server and the log error procedure outside the trigger. So I've minimized the changes to the trigger code as much as possible. This is where it might be tedious, because this has to be done for every field validation. But if you put that into a template, then you would not have to code it, because it will be exactly the same each time. Okay, so that's really the reason for not putting it into the error handlers themselves, but rather to keep, they are in the error handlers because they are in the error handler service program. They're embedded in the error handler service program, which is where they would be anyway if you put them into ERH 10, 5, 6, and 7. They would still be here, but you would not have the pointer to be able to drive it. You wouldn't have the trigger parameter list to be able to hand it to the log error procedure. Okay, does that sort of answer it? I can see from the expression on your avatar, you're not convinced. All right. Joel, have you got questions?
Yes. When IO server is calling this error, what I mean is when the IO is calling this, the program on the right,
Yeah.
what's the program name that is being received there? Is it the service program or the module name?
Well, are you talking about this log error?
Yes.
Yeah. This is a procedure name inside this module, server 03, which is then compiled into your error services program. So your ERR SRV at will be the service program that carries this procedure. So when you call,
yes.
Yeah, when you call it, that's what it will be called.
Okay, but let's say a program is IO is calling this, it checks the legacy. But when it checks if it's a legacy, what's the program name of the IO? Is it the service program or
The legacy?
yes, when you scan for the program name.
Oh, sorry, I'm not sure what you're asking.
He's looking for the PEP.
Yes, the PEP.
Next PEP.
The PEP, is it the IO?
This PEP will find the calling program. That particular code will find the calling program, and it will load the CSE data structure with that entry.
In the case of IO server, is the program name in the receive, is it the name of the IO or the name of the service program?
The service program is a procedure. It's not a program.
Okay, so I will have the name of in the case of product, it will be product $sign.
Yeah, the IO server is a procedure. Okay. I'm looking for program entry points, so it won't show up as a program. It only shows up as a procedure.
Okay.
Does that make sense?
Yes.
Yeah. So only in all of this stack of stuff, only this program here, or this program here will have a PEP. The trigger is a program, will have a PEP. So there's a PEP there and a PEP there, or there.
Okay.
The rest are all procedures, and that code will bypass them.
It bypass the IO.
It finds the first one, which it knows is the trigger, and then it goes looking for the next one, which it knows is the calling program. Because there can be no PEPs in between that. Because all the IO, all the RDBMS stuff is also procedures. I wonder whether I can find that. If we look, this is the workbench. I don't know whether I can find it. Let me do Shift Escape. 3 call stack. You see, all the Q stuff is not even a procedure. It has no procedure. It has a program name, but it has no procedure. So there's a procedure. There's W. So the UIM here is a procedure, etc. To be honest with you, to be absolutely honest with you, I've still got to test this. I haven't tested it yet. So now that we've come to the conclusion that you want a file and etc., I will clean up this code. I will do a template. Hopefully you'll try and do one too. And I will create a new trigger for the prod ord file that we have in the training environment with this style of trigger, so that we can, and I will debug it and test it out and make sure it's all working. As I said, I lost my original code, which I don't know what happened to it. Wish I did, because I would be very happy to know where it was, but it seems to have disappeared. But I will test this, make sure that I'm not leading you up the garden path, and then we can make absolutely sure that it is. Then you can go ahead and you can begin building triggers and test your building triggers for your 2 files. And then you can start testing and debugging your IO servers and your triggers all the way through on these 2 files that are in your product environment. Because I would like you to do that testing. Okay. That's my question page. So I leave you with the question page. And that's the end of the topic on triggers. No more triggers. All finished. But do remember that when I talk about letting the database do your heavy lifting, the trigger programs, both before and after, are the most powerful heavy lifters for the database to use. They can do all your validations, your provision of default values, your all sorts of things, your synchronization of your database, accumulation of summary stats. There are so many things that can be done in triggers that take such a load off your applications themselves. And things like calculating VAT. Let the triggers calculate the VAT, or the value added tax, or the sales tax, or whatever you guys call it. They call a procedure that calculates it for them, but your application program doesn't need to. Your file must have a column for the tax in it, but let the trigger calculate that tax. It's much easier than your application having to do it in 7 different places. So the things that the trigger can do for you are only limited by your imagination. And if you need the same thing to be done for every file, regardless. For insert, update, delete, then the trigger can do it. And you should focus on loading these triggers with as much of your application requirements as possible.
Tommy, I have
Okay.
a question.
Yeah.
Let's say I have a program that does have 20 F spec,
Okay.
but we just are we going to be able to just use half of them with IO servers and then leave the F spec for the rest, or it's gonna be?
You can. You see, this approach of is not a all or nothing approach. If you have 20 F specs, you can replace one of them with an IO server. And you can gradually, as you build up, you can replace more and more. Have you got programs with 20 F specs in them?
Oh, probably. No, we don't have that many, but I know that we have large programs.
Okay.
And we are not using that much logical files or join logical files and things like that. So,
well, there's the first thing, is to look at all those files and see exactly what you're doing with them. Maybe you can replace some of them with logical views if you're combining data from two different files. You might want to use logicals. You can also create an IO server, as I said to you, for a logical file. But you might also like to create another type of IO server which collects data from half a dozen files, consolidates it for you, and sends it back to your program with one IO from your program. You see, that's a trick you can pull as well.
Okay. But it's just that sometimes when you do a change to a program, you want to limit the change, because that when you do a change, sometimes you bring up a lot of validation and you don't want to break the program.
No, absolutely.
So,
I agree with you entirely. It's much better to do it slowly. You'll find as you go along, it gets easier and simpler to do. The thing is, if you take one file and you create an IO server, you may have 20 programs that use that file. You may come across a change you need to make to one of those 20 programs. So at that time, change it to use the IO server, but the others you don't have to change. Yeah. You see, and so you gradually, almost by, it's a process that every time my philosophy is, if you touch it, you fix it. And that's the steps you take. If you have to modify a program or fix a bug in a program or add function to a program, go through it. Fix the IO servers. Make IO servers if you haven't got any. Try and do as much fixing on that one program as you can without worrying about all the others. Then you can still keep the old methods. That's what this trigger is designed to do, is to allow you to start building in these trigger value validations and other stuff without destroying programs that you haven't touched. And quite honestly, there may be programs that you don't touch for 50 years. I don't know. In which case,
I don't know what is the oldest program that we have, but I'm sure we have very old programs. Yes, Joel.
Yeah, Joel.
Yes, I think I found the program for checking legacy we're talking about on our system. You want me to show it to you?
Yeah, let's see what you've got. Hang on, I'm just going to find it. Okay, I've got to kill the share, otherwise you can't. Okay.
Well, yeah, I found this. Can you see my screen?
Yeah.
Yes.
I found this check for legacy program procedure.
Goodness gracious me, where did you find that?
AOAB Canada.
Oh, goodness gracious me. That's a very interesting.
Maybe it's the old way you were talking about.
It looks like it was the old one I was talking about. It's done in pretty much the same way.
Yeah.
Joel, you can just attach it to an email and send it back.
Yeah, just send it to me in an email or something. Just I'd like to see it.
Yes.
Or in fact, tell me what scheme is it in? I can get it myself.
It was in
Well,
AOAB Canada.
AOAB
Like,
Canada.
AOAB Canada.
The file SRCTRG or something.
AOAB Canada. Yeah. SRCTRG. Heavens above. UTL services. So I put it in a utility services. That's the only difference. I made this a utility. I didn't think of putting it in with the error handlers. No. I don't. How did you get that, Joel?
Oh, I scanned legacy and on our system, and I found it.
First of all, how did you get it onto your system? And secondly, how did you know it was there and found it? Go.
Well, we have a library for Aero, so I just scanned it.
it's there since 2020, I think.
Is it? Is that the date on it?
Yes.
Yeah. 2020. My goodness, that's 4 years ago. That was the first time we ever met. I must have sent a lot of junk.
Yeah.
Yeah.
Maybe a bit before, but that was the utility. So
yeah. Okay. Well, I'll take it back and then see what. Maybe I actually surprised myself and had the same solution, because there is a list. You can see up the top. There's a list of libraries there. I had that solution even in those days.
yeah.
Absolutely amazing. All right.
I have one question for you, Tommy.
Yeah.
What about, let's say we don't change the F spec in a program, but we just allow the error handler. Okay, we just, instead of using our error handling,
Yes.
we integrate your error handling.
You can do that too.
Method. Okay,
Yeah.
so that way we're gonna get the message. The program is gonna get the message.
Yes.
Anyhow.
Yes.
But we need to change the activation group and things like that to make sure that the program is in a different activation group, probably not in the default.
Yeah, you need to pull it out, and you can put all your programs into one activation group. That's what a lot of people do when they want to start using all the ILE functionality, is they say activation group no, okay? Or sorry, default activation group no, but they don't put the name of an activation group in. And then it defaults to QILE, and everything runs in QILE. So you have the very first program that comes off a menu, for example, and you say default activation group no, and then all the others are star caller. And then you are running in one named activation group. So that's what most people do to start with, to kick off with. I tend to identify my function drivers, which are the menu option programs that you call from a menu. Call those a function driver. Make those activation groups star new, and all the subsequent programs are star caller, so that each menu option runs in its own activation group. That's my style of starting out with this thing. You can do either. But you can do the minimum and just default it. Then you can use the error handlers in your programs without using triggers, without using IO servers. You can move into this thing as gradually as you like.
Yep.
All I'm asking is please, please test it. I know it works, okay, but please test these things to make absolutely sure that you are comfortable that they are working.
Yep.
Because we don't, I don't need to have you trash your production system because of something I said.
We won't do that. Maybe Joel will, but not us, you know. Joel?
Joel, are you going to take that sitting down? Oh, all right, let's see.
Okay.
What have we got here? We've still got. I'm not going to start a new subject. The next subject is going to be user spaces. This, I think we will cut this one a little short and we'll start this. I'm sure you don't want to start it now. I haven't still got to share it. Yeah, that's the next topic is user spaces.
Okay.
I don't think you want to start that now. Please, I will work on tidying up this trigger and the error handlers. I'll send you copies. I will send you a template of the trigger, of the new trigger. You can play with it yourself. I'm not going to be able to do it today, possibly not tomorrow, maybe Monday. So please have a bash on your own, Joel. Joel, you seem to get lumped with it all the time, eh?
True.
He's gonna train us after that.
Is that how it works? I'm training the trainer. So they just listening to me so they can catch you out if you have a problem, eh, Joel? All right. I think that's it. I'm not going to start user spaces now. There's not enough time. So have a great day. And we'll see you on Tuesday. Marinus, you'll make that booking, huh?
Yes, I will.
Okay. Well, I hope this has been enlightening, guys. And we'll see you on Tuesday.
Okay. That was great. Have a great weekend.
I'll do that. Thank you very much. You too.
Thanks, the same.
I believe you've had a bunch of snow, so go skiing.
Oh, we did this morning. We had a lot of snow. Yeah.
So you're going
and Neil
skiing.
Neil is probably under a foot of snow already.
He says that 1.5 meters, he said to me earlier.
Yeah,
Meters.
they closed meters. They closed the road, the highway for 2 days. We got 1.5 meters of snow.
Oh boy.
Oh,
But that was that lake effect, Neil?
Oh yeah. I'm right on Georgian Bay, so the water hadn't froze over yet, so it just picked up all that moisture and bang, we got it.
Hey.
Oh boy.
Well,
it's only 1.5 meters. It's child's play for us.
All right, guys. Thanks a lot.
Okay, thank you.
And
thanks a lot.
enjoy. Ciao then.
Okay.
Thanks.
Thank
Bye.
you.
Bye-bye.
bye-bye.
Bye.
Bye.
I have a question, Tommy.